So, having understood the topics related to bond basics, now let us learn the concepts of asset valuations. Particularly in this session, we are going to learn the bond valuation. Okay, so before entering into the bond evaluation, let us define some of the important terminology we are going to use, okay, interchangeably, but we must understand where to use what and what we mean by this specific term. So, the face value of an asset. The face value is also known as the par value, which most of the time is denoted by F. Okay, it also equivalent with the principal value. This is just the amount which is printed on the face of the bond, and that is why the name called face value. So, a bond is selling at the par, meaning that bond is selling in the face value written on the bond price. Okay. Another term is redemption value. It is also similar to the face value. A bond's redemption value or the maturity value, that means what is the value you are going to get when the bond is matured. Okay. So, sometime it also denoted by C, but we will continue to assume that we are denoting here by M just to depend. But in your book you can see the redemption value is denoted by C. So, please don't confuse between the use of M and C here. In our case we are continuing to use M. So, this is the amount that the issuer promised to pay on the redemption date. So, in most cases the redemption value is the same as the face value. So, if a bond is coming with the face value, so when it is redeemed you are expected to get the same face value, and that is why most of the cases the redemption value is the same as the face value. Okay. The time to maturity. So, the maturity period, okay, it basically refers to the length of the time before the redemption value is repaid to the investor. So, it may be as short, okay, it may be as short as a few months or as long as 30 years or even longer than that also. So, we can even consider it as for the short term bond or a long term bond. Usually, we will consider short term bond means the bond which will mature within 1 year, okay, and the bond which is maturing after 1 year is usually considered as the long term bond. So, the time to maturity may be as short as few months or as long as 30 years or even more than that. Okay, and also the coupon rate. The coupon rate is the rate, okay, or rate of interest, okay, the usually denoted by R, or we will denote here by R. Sometime we will also say like they denote by I. Okay, so this is a rate at which the bond pays the interest on its face value at regular time intervals until the redemption date. So, this is the rate. Suppose that a bond is having 1000 par value with a coupon rate of interest is 8%, okay, mature over 5 period of time, or sorry, 5 years. So, you have to compute the rate of interest on 8% periodically, right, in such example. Okay, so what is intrinsic value of an asset? The intrinsic value of the security is the present value of the cash flow stream expected from the security and discounted at the rate of return appropriate for the risk associated with it. So, it is basically a measure of what an asset is worth, right. So, what is currently hold. Okay, so if the market is efficient, then the market price of the security should hover around its intrinsic value. So what is meant by efficient? See, for our curiosity, in finance, the market is efficient means that market incorporate all the available information. Okay, if market incorporate all the available information, then market is said to be efficient. In such market, it is expected that the intrinsic value is equal to the market value, okay, or the market price the bond or the asset is selling for. And therefore the statement, okay, if the market is efficient, then the market price of the security should hover around its intrinsic value. So we also sometimes need to know the intrinsic value of the asset or security you have, right? Okay, let us move on to understand what do you mean by the current yield of a bond. Okay, so it is basically computed as the market price, or it is also known as the running yield or the income yield. Okay, current yield is sometimes known as informally, although a running yield or income yield. Note that current market price may differ from its face value, right? Okay, for example, the bond having a face value of say 1000 rupees may be selling at a discount at 900 rupees, or may be selling at a premium at 150. Okay, so what is meant by this? So whenever a bond is selling, okay, less than the face value, we call it as bond is selling at discount. When a bond is selling at higher than the face value, then we will call it as bond is selling at a premium. So a discount bond usually sells generally lower than the face value, whereas the premium bond usually sells little higher than the face value of the bond. So in such case, what is the, in our example here, what is the current yield? Current yield is simply the interest amount earned divided by the market price as a percentage term. So we will simply compute current yield is equal to the annual interest rate or annual interest amount divided by the current market price multiplied by 100 to convert it into percentage term. Okay, so it is the interest amount divided by the current market price multiplied by 100. This formula is very simple, which can also in our actuarial notation we can write as this is simply the FR. Okay, F is the face value, R is the rate of interest retained in the coupon, that is okay. So the annual interest is simply this FR divided by P is the current market price, which you can convert it here. So now, so if a bond of face value of 1000 and a coupon rate of let's say 12% is currently selling for 800, okay, in such case the bond is selling at a discount, right? So in this discount bond, then the current yield of the bond usually computed as, okay, 12% of this 1000 rupees, okay, is 120 divided by the current market price, which is 800. So we'll have 120 divided by 800 multiplied by 100 will give us the current yield, which is 15% in our example here. Okay, so the current yield would be higher than the coupon rate when the bond is selling at discount. Note this thing, that whenever a bond is selling at a discount, then we will usually expect the current yield to be higher than the coupon rate which is printed on the bond. Okay. On the other hand, the current yield would be lower than the coupon rate when the bond is selling at a premium. Now, what is the limitation of current yield? See, the advantage is basically it is simple to understand and also simple to compute. But the limitations are it reflects only the coupon interest rate. Remember, the formula is simply interest divided by the market price multiplied by 100. So, we have here it does not consider the capital gain, okay, that an investor will realize if the bond is purchased at a discount and held till maturity. Okay. So, the current yield computation actually do not consider the capital gain or capital loss into account. It simply gives us how much is the yield if you hold the bond. So, that is interest amount divided by the selling price multiplied by 100. Okay. So, it also ignores therefore the time value of money what you have already learnt in previous sessions. Okay. So, current yield does not compound the interest rate. It will simply tells us the total interest amount divided by the current market price. So, these are the limitation of current yield. However, it is a simplistic measure of the. So, therefore, now let us understand little more appropriate yield which is known as yield to maturity. Okay, let us take this example. Suppose you face a decision to choose between two potential investment. The first one says a 3 years 1000 rupees face value coupon bond with a price of 1050 and a coupon rate of 8%. The second option is that a 2-year 1000 rupees face value coupon bond with a price of 980 and a coupon rate of 6%, right. So, you need to calculate the rate of return. Okay, you will receive on each and then choose which one you should choose, whether which one is appropriate for you, whether you will choose this one or you will choose the second one. Okay. So, our yield to maturity computation will allow us to choose appropriately which option is better for us. So, let us now learn the yield to maturity. I will come back to the example later once we understand the formula for yield to maturity. Okay. Of course, for one you can compute that the yield to maturity is equal to 6.1%, and for 2 you can compute that the yield to maturity is 7.1%, and you will choose therefore the second option is better for you. Okay. So, this calculation shows us that even though bond 1 may appear to be better investment because it has a higher coupon rate than the bond 2, bond 1's higher price means that it has a significant lower interest rate, or the return you are going to get is usually less or in fact comparatively less than the second option, that is second bond. Okay. And therefore, yield to maturity computation will give you the appropriate answer. Okay. So, if you wanted to earn a higher rate of return on your investment, you would choose definitely bond 2. I will come to it later how you get this 6.1% and 7.1% after understanding the yield to maturity fully. Okay. Right. So, the interest rate you just calculate, okay, this one is usually known as the yield to maturity, which just equate the present value of the payment from an asset with an asset's price today. Okay. So, basically the yield to maturity is based on the concept of present value and is the interest rate measure that economists, firms and investors most likely use. So it is important to note that unless they indicate otherwise, whenever economists or investors refers to the interest rate on a financial asset, the interest rate they mean is usually the YTM or yield to maturity. If it is stated appropriately, then we will consider, otherwise we will simply consider the interest rate as yield to maturity. Okay. So, calculating the yield to maturity for alternative investment allows investor to compare different type of debt instruments, and therefore yield to maturity is very popular, and most of the time the investors calculate the yield to maturity to compare the bond options they have, as we have seen here, the option 1 and option 2, and then you have chosen option 2 only after computing the yield to maturity. Okay. So, what is the yield to maturity? Let us understand this. It is basically the return on the bond investment if the investors hold the bond until the maturity period. Okay. So, until the bond matures, if you are holding the bond, then what is the bond actually worth? That is yield to maturity. Most widely used measure of the rate of return on the bond. So, YTM is the very popular and most widely used measure, and it also considered the time value of money, because every time the interest rate is compounded. So, it is the compounded rate of return an investor is expected to realize from a bond purchased at the current market price and held till maturity. Actually, it is nothing but the rate of or the internal rate of return IRR earned from holding a bond till maturity. What the bond, okay, yield if you hold or if you held till maturity. This is known as yield to maturity. Okay, I believe you have understood what is yield to maturity. So, technically saying, yield to maturity is the interest rate that make the present value of the cash flows receivable from owning the bond equal to the market price of the bond. Okay. So, mathematically saying, okay, it is the interest rate which satisfies this equation. This equation says MP is equal to C1 upon 1 plus R plus C2 upon 1 plus R square plus C3 upon 1 plus RQ, okay, will go on till Cn divided by 1 plus R to the power n, and we will also add the final price, that is the M divided by 1 plus R to the power n. Here in this equation, MP is basically the market price of the bond, and the C terms, please understand this C term is the annual interest. Okay, we are assuming here that the the effective interest is annually computed. Okay, it can be changed if the interest is computed semi-annually and monthly. We will just divide the interest rate by either 12 for monthly or semi-annually by 2. So, C is the annual interest, and M is here the maturity value. Sometime you will call like your book says it also C, but don't confuse with this C, and the C we are referring to here is the redemption value. So, M is the redemption value, or sometime we will call the face value also. Okay, these are expected to be same, and N is the number of year left to maturity, and R here is the yield to maturity. So, sometime you will write this R as simply YTM. Okay, replace this YTM here R. So, you can again rewrite this as same, or sometime you will write like 1 plus IY, 1 plus IY here, 1 plus IY here, to representing the yield to maturity. That is simply the rate of interest here. So you compute the R here, solve for R here in this equation, that will give you the yield to maturity. Okay. So this equation can also be written as, okay, MP is equal to summation of Ct divided by 1 plus Ytm to the power t plus m divided by 1 plus Ytm to the power n. In his case, sorry, this one is C, okay, Ct is the cash inflow from the bond throughout the holding period, and m is the maturity value at the end of the period, right? Okay. So this is the same equation, we can write it in the, remember that this part can be considered as the annuity part and this part can be considered as simply the interest rate factor. Okay, I will come back this to later, but here, okay, so just the same equation can also be understood from your book, that is the book Financial Mathematics for Actuaries by Chan and Say, which one you have already referred and I am also referring for some reason, but now my aim is here to explain you in more simplified ways, so I have taken in the other route, but that same equation can be written in this way also, right? In which case we have understood that this is simplicity, we have just mentioned, right, that this is FR, okay, face value time the rate of interest, okay, and yi here, sorry, and the iy here is the yield to maturity, and this C, okay, please don't confuse this C with the other, this C we have written there, this C usually M, okay, in our other equation we have written this C as M, okay, which is the redemption value or the maturity value at the end of the period. So this equation therefore is the same equation what we have developed in the previous slide, okay, with different notation, and therefore please don't confuse about this equation and that other equation. Having understood the equation correctly, okay, one can easily move for this. Okay, if the interest rate is compounded semi-annually or it is a semi-annually coupon bond, then this equation can be rewritten for semi-annually interest rate, then this can be, yes, in which case we will simply add this interest rate here is divided by 2, okay, and then we will multiply the total number of period with 2, and therefore here 2n and here it is 2n, okay, where j is equal to n. So you note one thing here, that for an annual coupon bond, okay, this is for annual coupon bond, right, and this is for the semi-annual coupon bond. So for an annual coupon bond, this IY is an annual effective rate, while for the semi-annual coupon bond, this IY is the nominal rate which is converted into semi-annual coupon rate. That is why this, if the interest is computed monthly, then it would have IY divided by 12, okay, and then we will multiply this 12 here with n, and then we will also write here 12, okay. So let us proceed to compute the yield to maturity. How to compute the yield to maturity? We have understood the formula. Now we will use the formula to compute the yield to maturity. We will take one simple example and we can see how to compute the yield to maturity, okay. But because in the formula we have, like the YTM is in the denominator side, so it is very like confusing for us to in fact compute the yield to maturity. One way is to compute the yield to maturity is through the process of trial and error. Let us first understand how we will use this trial and error process, and then I will tell you a simple approximation formula also. So let us take this example. Consider a 1000 rupees par value bond carrying a coupon rate of 9% matures after 8 years. Okay, the bond is currently selling for 800. What is the yield to maturity on this bond? So, here this is the face value of the bond and this is the interest rate or it is the coupon interest rate on which you can compute the annual like interest amount, and this is n, okay, 8 year, and this is the redemption, okay, or this like this is the current market price. Okay, this is not redemption, this is the current market price, that is 800 rupees. With this information, let us compute the yield to maturity. But here also, like in the yield to like in the current yield we understood, here also please note that when yield to maturity is greater than the coupon rate if the market price is lower than the par, okay, or if the bond is selling at a discount. So, for a discount bond, okay, for a discount bond, yield to maturity is usually greater than the coupon rate, okay. But for a discount or for a premium bond, in which case the bond is selling higher than the face value, okay, in which case here yield to maturity is less than the coupon rate, right. With this understanding, let us proceed to compute the yield to maturity. Let us do the solution. If yield to maturity is the value of R, okay, or in fact we will consider this because I have already written here YTM, so you no need to compute the R, the value of R in our previous equation although, okay. So we can have it here, right. So now we have to choose a different value, okay. We will simply rewrite this as summation of T is equal to n Ct divided by 1 plus R, okay, m divided by 1 plus R to the power n, in which case this R is exactly equal to YTM. Now our aim is to compute the R. So we will put different value for R that should give us the same MP, okay. So we will use it here. For example, in our case here 800 is the market price and 90 is the CT, that is 9% of 1000 rupees is 90, and then this is the face value or the redemption value here, right. So maturity value, M is here the maturity value or the redemption value, remember, and R, we have to place different value for R, okay. This equation also means that we can rewrite this as 90 multiplied by present value of interest factor for annuity. This can be like 90 multiplied by, okay, simply we can have like a n, okay, a n, right. This is the present value interest factor for annuity, given R is the interest rate. So using this formula you can compute this, and this is what 1000 multiplied by present value of interest factor, right, given R interest rate and 8 year which is given in the question. So see, this is simple present value interest factor, that is 1 upon 1 plus R to the power n, okay. So we will use this formula here and we will compute this as, okay, since the market value is lower than the face value as we have noted, it indicates that yield to maturity would be higher than the coupon rate. So coupon rate is 9%. So let us try little higher rate for the R, okay. Suppose that we will choose R is equal to 12%, which is of course higher than the 9%, okay. So in this case, place here, okay, R is equal to 12% and then compute the formula here, okay, compute the value here. So using this 90 multiplied by present value interest factor for annuity 12% and 8 year plus 1000 multiplied by present value interest factor, okay, with this 12% and 8 years again. So take this using the same present value formula, you will compute it as to 4.968. This is, remember that for this person it looks like annuity, and therefore we are going to use present value interest factor for annuity, okay, A angle N at I. So 90 multiplied by A angle, okay, N is 8 and I is 12% or R is 12%, then we can compute this at to 9.68. You can use your calculator to get this value, okay. Similarly, we can compute this for, this is simply, like this will be like present value interest factor, that is 1 upon 1 plus R, this part only, okay. So 1 plus 0.12 to the power 8, okay, we will compute this. So this is basically computed, this person, okay, for this person we will compute it as 90, okay, 90 multiplied by 1 minus 1 upon 1 plus R to the power N divided by R, okay. This is the present value interest factor for annuity, and for this person, okay, we will compute 1000 multiplied by 1 upon 1 plus R to the power N again. So please don't confuse about this. So this is your present value interest factor for annuity, which is 4.968, given R is equal to 12 and N is equal to 8, okay. Similarly, you will get this value, okay, A is equal to 0.404, which is equal to 851. This, remember that our aim is to choose this value should be equal to this value, and we have seen that this value is higher than this 800 value. So we cannot take 12% as the yield to maturity. We may use some different value, right? So since this value is greater than 800 rupees, we may have to try a higher value of R, okay, and suppose we will choose R is equal to 14%, and we will compute the same way. We will compute that the value will be 768.1, okay. You can use this with present value interest factor for annuity, given R is equal to 14% and same N is equal to 8, and PVIF, that is present value interest factor, given R is equal to 14% and N is equal to 8, we will compute it at 4.639 and 0.351 respectively, and this will amount to be 768.1. Now look at, compare this value with this value. So this value is lower than this value, so again we cannot take this 14%. So since this value is less than the 800 rupees, a lower value of R may be tried. So we will choose another value that is essentially lower than 14%, but remember that it should also be higher than 12%. So let us try 13%, okay. So let's R is equal to 13%, and again do the same calculation here, and we will get 808, okay. Again you will get this value with this R is equal to 13%, okay, N is same, so you will get 808. So now it look like this value are quite closer but not exactly same, okay. Then now we, at least we can think now that the value must be in between this 13% and 14%, right? It is not less than 13% and not higher than 14%. The value should be in between these two, okay. So like thus R must lies between 13% and 14%. So use the linear interpolation in mathematics, okay. in the range that is 13% to 14%. Use the formula for linear interpolation and you will get the formula. The formula says that is 13%, okay, plus 14% minus the 13% and the value which you calculated using, this is the value you have computed using R is equal to 13% and this is the market price, that is 800 divided by, this is again the value which you computed using 13% and this is the value you computed using R is equal to 14%, this value, okay. And now you will get the yield to maturity is equal to 13.2%, or like, sorry, here 13.2%, okay. So this is the way we will compute the yield to maturity using the trial and error process. But I believe like no one of us actually like the trial and error process, right? So the good thing is, like, we also have a approximation formula, okay. So the approximation formula given by Prasanna Chandra, okay, investment management, okay, like I will say, okay, certainly you don't like the trial and error, okay. So if you do not want to use the trial and error because it will consume lots of time, you can use the approximation formula which is given by the book Prasanna Chandra, okay. This formula is given in the book Prasanna Chandra and why it is very like clear and quite accurate. Please refer to Prasanna Chandra for bond valuation, at least in this. So I will call Prasanna Chandra investment, I think management, and just check with the book, okay, management, MENT, right. This is the book here, but you can sometime people also use like while yield to maturity, the approximation formula is like C plus M minus P upon N divided by, simply they will compute this as M plus P divided by 2. Sometime you will also get this, but here, okay, I will advise you to use this formula, okay, rather than this formula, but because this is very simple and we can use here using this person. But understand this formula now, where the C is the annual interest payment, okay, and M is the maturity value, okay, and the P is the current price at which the bond is selling, N is the the year to maturity, and we will use, remember, most of the time students actually confuse with this M and P, okay. In my, I have observed many students they confuse with this M and P. Please don't confuse. So 0.4 M, which is the maturity value, okay, and 0.6 P, which is the selling price. In our case here, M is 1000 and P is I think 800, right. So we will have here, so 90 plus 1000, that is M, and 800 is P, N is 8 divided by 0.4 plus 1000 plus 0.4 multiplied by 1000 plus 0.6 multiplied by 800 will give us 13.1%, which is very similar to what we have computed in our trial and error method, okay. And therefore this formula will give you the appropriate answer. You can just check for our curiosity that using this formula you will get a yield to maturity value around from 12.77%. Just check by yourself, you will get and then this is actually, there is a huge difference, right. And therefore I advise you to use this approximation formula, not this. Although you can see in internet also it is available, this formula. Okay, so using the same approximation formula, let us come back to the question or the problem we have asked initially. Then we will see that this one should be, the first problem is 6.1 and the second we will get 7.1, and that is why I said, like I have written this value initially to proceed this. Okay, so now I believe you have understood the computation of yield to maturity. Let us now discuss the advantages and disadvantages of, or we will call limitation of, yield to maturity. What is the advantage? Of course, advantage it considered the current coupon income as well as the capital gain or loss investor will realize if the bond held till maturity. Remember the last part actually in our equation, right? And also it takes into consideration the timing of the cash flow. That means it also incorporate the time value of money. One of the disadvantage of current yield is now captured here. But it also have some limitations. The yield to maturity also have some limitation in the sense that it do not account for any taxation or tax that investors face on bonds. If the investors is at all paying any tax, then the formula of yield to maturity does not incorporate the tax. So in this case, yield to maturity is known as gross redemption yield, which is not considered as tax. So also it does not account for purchasing or selling cost, if any. So if you incurred any kind of transaction cost or purchasing or selling costs, while making the investment, this also not incorporated in the yield to maturity. So the actual return depend on the price of the bond when it is sold, and therefore the market can fluctuate substantially. That happen, then you also need to take, uh, consider or take in account this approach also. So basically what I am trying to say is, like, while yield to maturity seems very popular, it also suffers some of the limitations. For example, it does not consider tax into account, it does not consider transaction costs or any cost that involved in the bond investment. But still we can use the yield to maturity to consider different bond options available for us, and accordingly we will choose one which is most suitable.